Hello friends, today I will discuss about measurement of DC resistance test of a transformer. Before going through this video, you are requested to please go through my channel and do subscribe my channel and also press the bell button for notification for videos to be uploaded in future. Now, why the winding resistance test measurement is important or done? Winding resistance measurement in a transformer are of fundamental importance for the following purpose. Number 1. For calculation of the I square R component of conductor losses, where R is the resistance of the winding. Number 2. Calculation of winding temperature at the end of a temperature test cycle. Number 3. As a diagnostic tool for assessing the possible damage in the field. And that is, measuring the resistance of the winding assure us the connection of the winding with the tap winding are correct. Winding resistance test measurement is done at the time of installation and commissioning of the transformer. Risk of damage is significant whenever a transformer is moved from one side to another. This damage can also occur during unloading and assembly times. The damage will often involve a current carrying component such as on-load tap changer. Damage to such component may result in a change of DC resistance measured through them. Hence, it is recommended to measure the DC resistance in the all number of taps before energizing of the transformer. Number 2. For routine maintenance work. Since OLTC is the non-static part of the transformer, it carries majority of the current during tap changing of the transformer. Therefore, to assess the tightness of the tap winding at all number of taps, it is recommended to check the DC resistance states for routine maintenance work. Also, it is done for unscheduled maintenance or troubleshooting for detection of the fault of the transformer to determine if corrective action is necessary to rectify the problem in the transformer and to determine if it is safe to re-energize the transformer after all the testing is done, including the DC resistance test. Many transformer fault or problem will cause a change in DC resistance measured from the bushing, that is shorted turns, open turns or port joint or contact. Hence, the information derived from the resistance test is very useful in analyzing the fault or problem. DC resistance test principle. The diagram shown for measurement of DC resistance test. Here, a DC test current is injected across the measured winding, and the voltage drop as well as the test current is measured, and the resistance is calculated by Ohm's law, that is V drop by I injected. Now, the mathematical expression for measurement of DC resistance test is shown in this diagram. Here, U is equal to R into I plus d phi, that is a function of current and time, by dt, where U is the voltage measured, I is the injected current, R is the resistance to be measured, phi is the flux, and T is the time. Now, inductance L, that is function of I and T, is equal to phi by I. Phi is also a function of I and T, time. By putting the equation of L into the above equation, you can get U is equal to R into I plus D L. L is a function of I and T into I by dt, that is U is equal to R into I plus L into di dt plus I into dl dt. Our motive is to calculate the only R into I and to eliminate the second and third term. The second term eliminated by waiting for current to stable over a certain time, that is, it is normally takes a few seconds to stable the current, and the third term eliminate after the flux get saturated or flux get at the point of fixed after some certain time. In this diagram, it is shown that current is steady after some time, and therefore apparent resistance can be measured when the current is steady, and flux is steady as per BH curve as shown in this diagram. During testing of the DC resistance test, first we have to open all the jumper to the HV and LV bushing, and then also open the earth flat connected to the neutral if it is a Y connected transformer. We have to ensure the test leads are securely attached to the winding terminal. Do not operate any instrument control which would open the measure circuit while DC current is flowing. Discharge the winding first. We have to ensure that do not disconnect any test lead while DC current is flowing. Ensure the winding is discharged first. When terminating the test, we have to first discharge the DC current as shown in the winding resistance tester. Goes up and current goes to the zero value. When testing larger transformer, it may takes 30 seconds or more to discharge the winding. If a longer time is required to charge a winding when the current is initiated, a corresponding longer time will be required to discharge the winding. Must be ensured that after the discharge fully, the connecting leads should be removed for next testing in the next phase. Measurement instrument for DC resistance test has been shown in this diagram. In this diagram you can see that left hand side there are three number of channel. One channel is for potential input, and remaining two channel is for current 1 and current 2 channel input. There are two display, channel 1 and channel 2. In this winding resistance test, we can measure the two number of phase resistance of the two number phase simultaneously for Y connected transformer. In the lower hand side of the right side of the diagram, there are three knobs. One is for current selection of current injected, that is it can be selected from 0.01 to 10 ampere, and the left and right hand side knob is for selecting the range of the resistance to be measured. Now how the test arrangement is done for measurement of a power transformer for YND1 has been shown in this diagram. First, the resistance of test is done in the primary or Y connected transformer. We have to remove the earthing flat from the neutral winding. Then we have to connect the voltage lead as shown to a one phase, that is in between R phase lead to the neutral lead, and also connect two terminal for current lead to the R phase lead to the neutral lead, and then we have to connect the other two terminal for voltage and current lead to the current channel and potential input channel in the test kit. Then in the test kit we have to select the proper current injection, and that is normally it is set as 1 ampere and sometimes it is also set for 10 ampere. Then we have to test current, it must be on, and soon the current, wait for current to stabilize. When the current is stabilized, the channel 1 or channel 2 has previously said will show the resistance measured through the test kit. During measurement of DC resistance test, we have to note down the oil temperature. In this diagram, in this table, the measurement resistance for different tap winding has been shown. For the primary winding for R phase, Y phase and blue phase for a YND1 transformer. Here the transformer capacity is 50 MVA. U represent as R phase, V represent as Y phase and W represent as V phase. Here the different taps the resistance measure is shown. It can be seen that from the above table that the measured resistance at tap number 8 and 10, at 6 and 11 and 5 and 12 respectively are almost should be same. Now in the test kit, how two phase resistance can be measured for Y connected transformer simultaneously has been shown in this diagram. Here the potential input channel, that is voltage lead of one of the terminal, must be connected to one phase and other terminal to other phase. Here the voltage lead is connected to in between R and B phase lead, and two current channel input is connected in between R and N, and another channel current lead is connected to blue and N. Here in between channel 11 and channel 2 will show the resistance of R phase winding and B phase winding respectively. How the resistance of the delta winding can be measured has been shown in this diagram. Now for delta winding, if the resistance of the each phase winding is R, the R measured should be equal to 2 by 3 into R. Therefore actual R can be calculated. Actual R is equal to 1.5 into R measured. The test result for each phase of the delta winding transformer has been shown in this diagram. The measure resistance in between 2U and 2V is 30.6480 milliohm, and in between 2V and 2W is 30.680, and in between 2W and 2C is 30.7140. Here the measured resistance is independent of the changing of the tap in the primary winding.